The human body is an incredible thing, made up of billions and billions of cells. Contained within most of our cells are the instructions needed to make us, our genome, the complete set of human genes, packaged in 23 pairs of chromosomes and comprised of over 3 billion letters of DNA. Our genes are short sections of DNA, inherited from our parents, that contribute to who we are. But differences in our genes can also cause disease. Millions of people in the UK alone are affected by inherited conditions. Some are rare disorders affecting a few thousand people. Other conditions are more common and are often the result of our genes and environmental factors, like viruses, pollution, and our diet. Here we look at how modern genetic research has played a large part in helping us to understand two very different conditions. Susie Murray had her first heart attack at 23. She suffers from a rare heart condition called long QT. Long QT is a disease affecting the sodium and potassium channels in the heart and leads to an irregular heartbeat. Left untreated, it can lead to rapid heartbeats, blackouts, and at its most severe, sudden death.
My sister died in 1999. At the time of inquest, we were told it was sudden adult death syndrome. We didn't really know very much about the condition. Then my daughter died in 2002 of the same condition, and then they, at that time, realised that it was a genetic problem, and we were looking at long QT because I'd become symptomatic as well by that time.
The diagnosis of long QT rests on two things. One is the clinical history of the patient, and the other is the characteristic findings on the ECG.
In many cases, long QT can be diagnosed with an ECG or heart trace. The ECG shows the electrical pattern of the heart. There are 5 main points on the ECG: P, Q, R, S and T. In people with long QT, the interval between Q and T on the ECG is extended. However, in Susie's case, the ECG wasn't clear-cut, but her family history could not be ignored.
It wasn't really until my daughter died that I was in the cardiac unit as a patient, and the cardiologist I was seeing there referred me to my specialist now, and straight away when I told him my story, he put in a defibrillator. He implanted one in for me because he realised the risk that I was under and the rest of my family also was under.
An implantable defibrillator is similar in many ways to a pacemaker, but instead of stopping slow heartbeats, it stops rapid heartbeats. The idea is that if the patient develops a rapid heartbeat, the defibrillator will sense that, and after a few seconds will deliver a shock to the heart, causing the heartbeat to return to normal.
Susie's son Alex was also tested for long QT, and although his ECG didn't show anything, they decided that at the tender age of 11, Alex should be fitted with a defibrillator too.
I wasn't diagnosed, but I was fitted with the pacemaker and defibrillator as a precaution to make sure that if I did have it, it's there and it can save me if it's needed. The recovery took a long time. I went to my cousin's birthday party after, and it was quite hard for her to understand because she couldn't come running up to me and hug me like she normally would, because I'd been in bed for about 3 weeks and I was very frail and weak.
Having the defibrillator fitted meant there were some sports Alex couldn't do, but it hasn't held him back from doing most of the things he really loves.
I can't do most contact sports, but I still do my Muay Thai, which is basically Filipino Thai kickboxing, which is fun, but I have to be careful and wear bodyguards. My defibrillator hasn't held me back in any way. I earned these fair and square, and I carry on doing the sports I enjoy.
Genetic diseases are the result of changes or mutations in our genetic code. In our bodies, our DNA has to be copied many times in order for us to grow. These copies are then copied again and again. The more times the DNA is copied, the higher the chance that mistakes can occur. Often these mistakes or mutations have no effect on our health, but in some cases they can lead to disease. In the case of long QT, which is known as a single gene disorder, a mutation in one gene can lead to an individual developing the condition. Dr. Bill Newman is a clinical geneticist at St Mary's Hospital in Manchester and specialises in studying these gene changes and in developing tests for families with inherited conditions.
We undertake genetic testing to see if we could find the gene change. In about a quarter of cases, when we do the testing, even in patients who we know definitely have long QT syndrome, we're not able to find the specific gene change.
Susie and her family have had a genetic test, but their results were inconclusive. Like so many things in genetics, nothing is clear-cut, and although long QT is a single gene disorder, there is actually more than one gene that can cause it.
At the present time, we look for changes in 4 genes that are most commonly affected in long QT syndrome. We know that there are at least another 8 different genes that can cause the condition, but for a number of reasons, mainly technical reasons, it's very difficult to look at all of those genes given our current techniques.
Genetic testing can help patients and their families make some important decisions in their lives, but it's not straightforward.
I do have concerns for the rest of my family. When you're given a diagnosis of long QT, it makes you make life-changing decisions. I know that my brother has decided not to have a family because of the risk of passing it on. Although, had I been younger and faced with the wishes to have a family, having lost a daughter, I still would have gone on. Because in some ways, yes, maybe it is selfish to perpetuate the condition. Medical science has moved on so far that, if you can lead quite a healthy life, if, you're one of the people that gets it. Certainly, I look at Alex and can use that as as an example.
Unlike rare single-gene diseases, such as long QT, most diseases are due to a number of genetic causes and environmental factors. They are known as common and complex conditions and include a huge range of very different diseases, such as cancer, diabetes and eczema. Dawn has a history of skin conditions in her family, and her young children, Aiden 9, Tegan 10 and Ryan 11, all have a number of skin conditions, including eczema.
And I've never had a night's sleep out at Aiden since he was born. That's 9 years.
It gets itchy and I start scratching it and it gets sore and it gets worse too.
There is family history with the skin conditions and that. My husband's got allergy side of things with dermatitis. My mother's also got dry skin, which I've inherited as well. So obviously the children and that's become affected in whatever ways. So.
When I was younger, I had quite bad. As for now that I've been growing older, it seemed to wear off, and now I've only got it on my hands and my feet.
He's been tested for contact allergies. He's allergic to leather, nickel, lanolin, cobalt chloride.
Also, if you're picking up shopping bags and they go into there, they really hurt your cuts there. And you can end up really sore. My sister and my mum are shopaholics, so it's usually the boys doing the carrying, so it's quite hard.
Eczema affects about 1 in 5 children in the UK at some stage of their childhood. Professor Erwin McLean and his team at the University of Dundee have been investigating the causes of eczema for a number of years.
Eczema is not purely a genetic disease. There are in fact 2 very important factors which lead to eczema. First of all is a genetic predisposition. So there are predisposing genes. The more of those genetic factors you have, the more likely it is that you're going to get eczema. The second thing is the environment. So there's something in the environment, we don't know what it is currently, that triggers eczema in people who have the eczema predisposing genes.
When Irwin began investigating eczema, he already had a hunch that a protein called filaggrin might be involved. Filaggrin, stained black on this slide, is usually very abundant in the skin and has the dual role of forming the skin barrier layer and also hydrating the skin barrier, so it acts as a natural moisturiser. Previous research had also shown that some people with eczema lacked this protein, so Irwin and his team began looking for an association between filaggrin mutations and people with eczema.
One of the tools we use in complex trait genetics to study common diseases such as eczema is called the Case Control Association Study, and it's outlined here in this diagram. What we basically do is collect a group of cases with the disease, in this case 262 DNA samples from children with eczema. And then we also collect population control. So this is a general population matched to our eczema cases.
So Irwin counted the number of filaggrin mutations in the case population, those with eczema, and then counted the number of mutations in the control, or general population. Statistical tests showed that if you inherited one mutated allele from your parents, you had a 40% chance of getting eczema. But if you inherited two copies, that risk rose dramatically to 90%.
It's not ever 100%, so you can't say it causes eczema, but it puts an individual in a very high risk group.
Understanding the role of filaggrin means that scientists may be able to develop drugs which help make this skin protein. But what about the eczema sufferers who don't have filaggrin mutations?
Eczema is a complex disease. The filaggrin gene is a particularly powerful gene, but there are several other genes, the identities of which we are now only starting to identify using genome-wide association studies.
Genome-wide association studies is a new technique that's used to search for genes involved in common diseases. In Irwin's filaggrin experiment, they were testing for a gene, but a genome-wide association study scans the whole of the human genome, looking for small bits of DNA that are different. As before, you compare one group with a disease to one without to see what the differences are. These studies are much larger and take longer to do, but Irwin hopes this will help him to find other genes associated with eczema.
The genome-wide association studies, which is a key tool to identify complex trait genes, has only been in existence for less than 5 years. So it's a fast-moving field. It seems probably frustratingly slow to the patient, but it's moving very rapidly now towards knowing most of the genes for common diseases.
For Dawn, hearing that her children's eczema was an inherited medical condition actually brought her a huge sense of relief.
It's gotten a lot easier now. I mean, I understand it's a medical side of things. It's not anybody's fault, so to say. But the children, they're all happy. They've all learnt to cope with it. And they're all smiling. There's worse off, you know.